During the Cold War, in the tense rivalry between the United States of America and the Soviet Union, every technological breakthrough became a point of national pride and ideological proof. When the Soviets launched the Sputnik in 1957, the first artificial satellite, they stunned the world and ignited the space race. In 1961, Yuri Gagarin's historical orbital flight deepened Americans' anxiety. If the Soviets could put a man in space, what else they might achieve? The President John F. Kennedy seized the moment. In his 1962 address at the Rice University, he declared, "We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard." This bold promise galvanized NASA, Congress, and American public. Behind the closed door, engineers raced to master the rocketry, life support system, and precision navigation. Publicly, each test launch and splashdown was heralded as a proof of a democratic resolve. Yet, by the early 1970s, after the triumph of Apollo 11, 12, 14, 15, 16, and 17, the flames of the lunar enthusiasm flickered low. The geopolitical imperative that has driven millions to watch the rocket launches fell away. Domestic challenges from the civil rights to the Vietnam competed for the attention and resources, and NASA budget contracted, and the moon became the old news. Now, after more than the half century of waiting, humanity gaze turns once more towards our closest celestial neighbor. NASA Artemis program is destined to send us farther than the Apollo ever did, and to stay on the moon. So, the mission will be divided. In the first part will be Artemis, which has been launched on November 2022, proved to be power of the new space launch system. Artemis 1, launched in November 2022, proved the power of the new space launch system and the resilience of the Orion capsule on the deep space voyage. And now, the Artemis 2 will carry the astronauts around the moon for testing the life support system, communication, and navigation system in the lunar orbit. And finally, the Artemis 3 will finally return the human to the lunar surface, this time to the South Pole, where ice is deposited, hints at the water and the fuel for the long-term habitats. So maybe this time, NASA isn't just going to the moon or putting the foot on its surface and return. It is going to the moon to stay and start the humanity's dream of reaching to the other celestial bodies in our solar system, such as Mars or maybe Jupiter's moon. So, the Artemis first marked the beginning of the bold new era in the space exploration. As an uncrewed 25-day test flight, it was designed to be the first in the series of the increasingly complex mission that would pave the way for the humanity to return to the moon. On November 16, 2022, NASA's Space Launch System (SLS), the most powerful rocket ever built, roared to life, carrying the Orion spacecraft into the space and sending it hurtling towards the moon. Over the course of a 3.5 week, Orion traveled approximately 1.4 million miles, reaching to the point thousands of a mile beyond the moon, farther than any spacecraft built for humans have ever gone. But this wasn't just a joyride. Every part of the mission had its purpose, such as testing the deep space navigation system, measuring the radiation exposure levels on the astronauts, tracing the system in the lunar gravity, and pushing the Orion heat shield to its limit during the blaze re-entry to the Earth atmosphere. So in many ways, Artemis 1 was complete success. It proved that the SLS and Orion were up to the task for putting the man or putting us on the moon. But it also delivered quite few surprises. During a re-entry, engineer noticed a small piece of shattered materials flake off the Orion's heat shield. But while this didn't compromise the space capsule integrity, it raised an important question. NASA engineers paused to investigate, ultimately confirming the capsule was safe for crew. Still, a minor adjustment were made. A change in the re-entry trajectory to reduce heat and redesign the life support system valve just to be safe. So, with this lesson, Artemis 1 was successful, and towards our next mission, which is Artemis 2, which will carry the astronauts around the moon for the first time for over 50 years. So, the human will leave low Earth orbit in 2025 or in 2026. Artemis 2 will carry the 4-person crew farther than anyone has ever gone before on a historic mission around the moon. Reed Wiseman, which is the mission commander, and Victor Glover, the pilot, and Christiana Koch, mission specialist, and Jeremy Hassan, mission specialist from the Canadian Space Agency, making the history as the first non-American to fly to the moon, launched atop at the Space Launch System, NASA's most powerful rocket. Artemis 2 will lift off from the iconic Kennedy Space Center. As the rocket pierces the sky, the crew will blaze beyond the Earth grabs, entering a domain untouched since the Apollo era. Over the next 2 days, the astronomers will remain in Earth orbit, carefully testing the Orion life support system, navigation, communication, and all safety-critical functions needed for the deep space survival. Then comes the moment of truth, the translunar injection. With a fiery burn from the Orion's European-built service module, the spacecraft will accelerate away from the Earth and begins to bear a trajectory towards the moon. This daring path will slingshot the crew around the far side of the moon, reaching a maximum distance 230,000 miles, maximum distance of nearly 230,000 miles from Earth, approximately 4,600 miles beyond the moon's far side, that farther than any human has ever traveled. So, it's next step towards a permanent human presence on the moon and a bridge to Mars, and a bold man return to human exploration beyond the Earth orbits. So, a path as elongate as it's efficient. By the slingshotting orbit behind the moon, the spacecraft uses gravity itself to curve back towards the Earth. And this clever route means no massive engine burn is needed to come home, just the pull of the gravity and precise planning. So basically, they are saving a lot of fuel in this. And saving a fuel means saving $1, which is every worth cent. And during the outbound journey and the 4-day returns, the crew won't just be along for the ride, they will be monitoring every system, performing the flight trajectory demonstrations, conducting medical checks, and ensuring the Orion life support functions work seamlessly under real space flight conditions. Along the way, they will witness something few humans have ever seen, an Earthrise view from the dark side of the moon, just like the Apollo 8 crews in 1968. It's more than a view. It's a shift in perspective, a reminder of our fragile place in the cosmos. After about 10 days in space, Orion will return home, straying through Earth's atmosphere at an astonishing Mach 32, over 39,000 kilometers per hour. The capsule will endure the temperatures hotter than the molten lava before finally splashing down in the Pacific Ocean, where recovery team will be standby. It's a crucial human flight test, the moment when we send astronauts beyond the Earth orbit to verify the Orion system, not a simulation but in space. And that data they bring back will be determined one thing: is Orion truly ready to carry humans to the surface of the moon on Artemis 3rd? So if all goes well on Artemis 2, the next mission, Artemis 3, will finally land astronauts on the moon, targeting September 2026. Some estimates may say it is 2027, since delays happened all the times in these big missions. But this will be humanity's first crewed moon landing in more than 50 years. Artemis 3 launched aboard SLS Orion into the lunar object. Then, 2 crew members will board NASA's Human Landing System, a SpaceX Starship, and descend to the lunar surface, while other 2 astronauts remain in the lunar orbit aboard the Orion. So, have you ever wondered why NASA chooses the moon's South Pole region for landing? Because its permanent shadows crater may harbor water ice and other precious resources. In October 2024, NASA identified 9 candidate sites within the polar region, from the high peaks like Cebus B and Mons Monton to crater rims like D. Garleche, each offering broad scientific potential. These unexplored high-altitude areas present challenges: cold, low sun angles, and communication constraints, but they also promise to reveal ancient lunar geology and clues about volatiles like ice. Two astronauts will spend about a week on the surface conducting spacewalk to collect the rocks and ice sample, operate drilling and experiments, and set up the equipment, effectively establishing the first long-run lunar base camp. They will wear the next generation exosuit suit designed by the Axion Space, which allows mobility in the deep space, and other two crew members in the orbit will conduct science, run communication relay with the Earth, and prepare for the rendezvous. After completing the surface operation, the Starship lander will lift off from the moon and dock with the Orion, reuniting all the four astronauts for the return trip home. The crew will then splash down on the Earth after roughly 30 days from the launch. Artemis 3 will also make the history on the symbolic level. NASA has pledged that this mission will include the first woman and the first person of color to walk on the moon. In that way, Artemis fulfilled the vision to set out for beginning to the land diverse crew and inspire the new generation of explorers back on Earth. Every footprint left on the moon's dusty surface will leap forward for humanities. And of course, returning to the moon is no easy task. NASA has already encountered technical challenges, and NASA announced that Artemis 2 will now target September 2025 instead of 2024 and Artemis 3 September 2026 to allow extra time to resolve the issue. The top priority is the crew safety, since if there is no crew left to come back, then there will be no hope for us to go to the moon, and maybe other space agencies will look the opportunities and took the risk and make us successful rather than the NASA. So some engineers have also found the unexpected problems in the Orion life support system during the testing. For example, a faulty valve in the cabin's CO2 scrubber has to be redesigned. As noted earlier, Artemis' first heat shield shed charred pieces during the re-entry. NASA conducted a thorough investigation and concluded that modified re-entry trajectory can keep the capsule within the safe heating limit. Once that fix is confirmed, Artemis 2 crew will fly with confidence. Meanwhile, the development of the human landing system is also a major risk NASA chosen lander. SpaceX Starship HLS is essentially an upper stage of the SpaceX Starship rocket that will dock with the Orion and ferry astronauts to the surface. But the Starship has never landed on the moon before. NASA requires SpaceX to demonstrate at least one uncrewed landing and ascent on the lunar surface before Artemis 3. SpaceX Artemis contracts involve an unprecedented fueling operation. Multiple Starship launches to build a cryogenic propellant depot in the Earth orbit. Then one Starship to load, then a fuel and fly to the moon. These tests of in-space refueling and rapid reusability are still underway. The first fully successful booster catch using SpaceX tower was achieved only recently, a key step towards demonstrating Starship rapid turnaround. Each test flight of a Starship provides valuable data, but also reveals new challenges. In short, NASA is letting the hardware talk and taking the extra sweet time to get it right. And then there are schedule pressures to NASA. The Inspector General report and hearing on the Capitol Hill have highlighted the risk of the slipping timelines, but the NASA's leadership insists on a realistic approach. As Artemis Deputy Amit Kashyap put it, they must be realistic about the pace and give partners the time needed to deliver the safe system. In practice, this means mid-2025 for Artemis 2nd crew launch and possibly 2027 for Artemis 3 landing. If Starship tests run long, even every delay is costly and disappointing, but slow down on the ground will save lives in space and could also save the future for the space exploration. Artemis is more than a two mission. It's an entire campaign. NASA and its international partners are building Gateway, a small space station that will orbit the moon as a tagging hub. Gateway, first two elements, a power propulsion module and a living quarter, will launch together on the SpaceX Falcon Heavy by the late 2027. Astronauts will leave and work at the Gateway, using it to dock Orion and reach the lunar surface by Artemis 4 around 2028. The crew will launch to the Gateway, then descend to the moon, just as Orion will dock with the Gateway instead of the Earth orbit. Gateway is being built by an international team, NASA, ESA, CSA, Texas, and UAE, and will support science like study internet, like study solar radiation and lunar environment, and technology demonstration. It will have multiple docking ports and a large solar array and the first airlock built in Europe. In future missions, getaway modules will also help to transform the crew to Mars, a part of a Moon to Mars strategy. The Artemis program is truly global endeavor. Canada contributed the Canadian tree robot and provided astronaut Jeremy Hassan for the Artemis 2. Europe, Japan, and UAE are providing the gateway components. SpaceX and Blue Origin have commercial contracts to land astronauts and cargo on the Moon. NASA regularly emphasizes that Artemis' success relies on these commercial and international partnerships. Together, this coalition is building a sustained lunar presence. And it all points towards Mars. NASA called Artemis the first step of its Moon to Mars architecture. We are basically building an infrastructure in space to go beyond the Moon, beyond the Mars, or maybe beyond our solar system someday. Someday, there may just be a news for us to hear that we are developing a spaceship which has capacity to go beyond the Pluto. But still, for making that dream come true, we still need to do some groundwork on it. Since there is no point in yapping about something which we cannot achieve towards our current technological progress. But someday, if we manage to go beyond our Moon, then we can successfully develop various new technologies, since when we go to the new surfaces, new areas, it is bound to happen for us to develop a new science.
If you like this video, please like, share and subscribe to the channel. I will really appreciate it. Till then, see you around and stay safe.